So I'd just like to say you're all pretty awesome. We've come a long way. It wasn't that long ago we were procuring servers, and it took like 6 months, right? We were installing Linux on a CD and a 3-com network driver on a floppy disk, and then we were, giving that server a name, South Park character, Simpsons character, whatever your poison was, and it all took 6 months just to get a dev server. And with FTP files into a CGI bin directory, what the hell is that? Whereas now, as the modern DevOps practitioners, we're using config management, infrastructure as code, we're using the cloud, and instead of 6 months, we're getting a server in 6 minutes. And that's pretty cool. So as a modern DevOps practitioner, I write some code, and I run some code, right? And so I have some Go code up here, and from that, you know a couple of things. One, I'm pretty cool, I use Go. And two, I need to compile this thing. So locally, for testing, I'll compile this on my laptop, but I need to compile it and put it somewhere I can use it in production. And so that's where I have Jenkins. I'm not cool. And Jenkins will watch GitHub for me, and when I make changes, it will actually perform a build, and it'll push that build somewhere where I can access it. And then I write config management, and I'm writing 100, 1,000 lines of YAML, a bunch of templates, to configure my operating system, going from bare bones to something that can run my application. And that involves configuring a lot of shit, like NTP, bind, setting file handles to something more than 1024 because it's not 1993 anymore. Thank you, kernel developers. And then I want to be able to run this thing on my laptop as if it was production. So I'm writing some Vagrant files to manage VMs and run my config management across those VMs. So I have it running on my laptop like it's running in production. But to run it in production, I need to write some other code, Terraform, cloud formations, something along those lines, to actually configure cloud resources, instances, networks, load balancers, all that sort of stuff. And then back to my old friend Jenkins, where I have a push button, or maybe I tell a Slack bot, which then tells Jenkins to run all of those things for me in hopefully the correct order to end up with a production environment, a staging environment, whatever I'm trying to deploy, and also deploy my code up there and actually get a working website. And that's pretty cool. If you're at this stage in your DevOps path at the company you work at, you should be pretty proud of yourself because we're in that top 10% of people. There's a lot of folks that are actually still basically installing Linux on a CD. Hopefully they've got the 3-com network driver into the kernel by now. And it's all reproducible, it's repeatable, it's all code, and it is pretty awesome. But there was a lot of code. There's a lot of cognitive load up in my brain trying to remember how everything fits together, how everything works. And so while the machines have gotten pretty good, I've probably introduced a lot of bugs along the way, which may not necessarily show up until 3 a.m. So what I want to show you is how my workflow has changed a little bit since I started using Kubernetes. So I have that same Hello World app written in Go, but instead of compiling it, I build a Docker image, and that compiles it inside the Docker image, so I'm still compiling it. But that also gives me an artifact. And then to deploy that, I just have a Kubernetes manifest, and there's a YAML file that tells Kubernetes how to run my app. Then instead of Vagrant, I use Minikube, which basically does the same thing. It just creates a Kubernetes cluster on your laptop. I build the Docker image, I tell Kubernetes how to run it, and then I curl it, and it works on my laptop at least. Then, of course, my old friend Jenkins, because you can't get away from him, I configure him up so that when I make changes to my code, GitHub hits a hook on Jenkins, it builds my app in Docker, it pushes it to a Docker registry, and then I have another push button or a chat bot or whatever to then tell it to run my Kubernetes manifest to deploy my application to Kubernetes. And I think that's pretty good. We've reduced a bunch of code that we have to write. We've reduced a bunch of cognitive load that I need to know. I'm not configuring NTP servers or DNS servers or anything like that. That's all handled by the platform from under me, and I just care about my application itself. And we all know the CAMS model. We all know the feedback loops. And this is really helping, I think, in the automation side of things. We are increasing velocity. By reducing complexity, we are reducing potential defects. And hopefully, we're improving our consistency and repeatability. This is a DevOps guide to Kubernetes. I am Paul Czarkowski. I am a sysadmin who practices DevOps, and I contribute to open source. And I'm a developer advocate at Pivotal Software. I don't actually know what that means, so I just go places, I talk about stuff that I find interesting, and I occasionally say the name Pivotal Software, and they're still paying me a paycheck, so I think I'm in the ballpark of what I'm supposed to be doing. But when I grow up, I actually want to be a barbecue pitmaster, so when I open my food truck, come on by and I will make you some barbecue. Now, DevOps, we've heard this people talking about DevOps, for the last day. We're going to hear more people talking about DevOps. So I'm not going to try and define DevOps or anything, but I did want to talk a little bit about our organizations and how we structure them. So you've all worked here, right? You all probably still work here. We have a bunch of technology teams that don't really interact very much with each other, apart from saying no over Jira tickets. And then someone like Michael Cote came in and spoke to our executives, and he talked about digital transformation. And our executives are like, wow, that's amazing. We need to hire a DevOps team. And so we hired a DevOps team, and we said, you got to write some config management, you got to write some infrastructure as code, thanks. And then someone read the Google SRE book and said, shit, we need some site reliability engineering. So we hired an SRE team, and we said, you're running our applications now, here's some PagerDuties, have fun. And we didn't really solve anything. We didn't get to that DevOps nirvana of having just one team all working for a common goal. We created more teams and some really weird job titles. And I think what we really should have been done is focusing on function and building cross-discipline engineering teams based on those functions. And so for a large org, you have infrastructure, so you have an infrastructure team made up of engineers that do, software development, QA, infrastructure experts, etc. And then you have a platform team that consumes that infrastructure. And they're doing things like running Kubernetes, Mesos, Cloud Foundry, platforms like that. They're also running common systems across the org. They're running, centralized logging, centralized logging and monitoring. They're doing databases, Kafka, kind of a lot of middleware tools and stuff that everyone across the org needs to use. And you have the application team that is writing applications, and they're consuming services from the platform and infrastructure teams, which are provided to them in hopefully easy-to-use abstractions. And then you may have an SRE team off to the side, where when your applications hit a certain amount of maturity and operability, you basically go to the SRE team, and if you fit their criteria, they offer to run your application for you. And then these teams are not necessarily built into your company. They could be external. For example, if you're using Kubernetes from GKE, Google actually becomes part of your infrastructure team and your platform team. And that's cool, because they are way better at running Kubernetes than you are. And that's, the culture, sharing aspects, that's helping improve that. So hopefully we can move towards that sort of cross-functional teams rather than just adding more teams. I did say I was going to talk about Kubernetes, so I should actually probably talk about Kubernetes. We can't do that without talking about Docker. Fortunately, we've had 3 years of people standing up here talking about Docker, so I can skip a couple of slides. We do still need some sort of build service and some sort of Docker registry for Kubernetes. It doesn't come with them by default. Some distributions of Kubernetes will provide them off to the side, but you still need them. So you need a build service, Jenkins, or something a bit more modern, I hope. And then Docker registries, you've got a bunch of options. Kubernetes is a container orchestration system that was originally developed at Google to replicate an internal tool called Borg. And so Google themselves don't use Kubernetes. They run Kubernetes in GKE, but they don't actually use it themselves. That may change in the future. So, it's kind of how Google does things, but it's also not how Google does things. It is production ready, unless you need one of the many features they haven't implemented yet, which is a lot. And it has a rapid release cycle. They're releasing every 3 months. And they're currently, I think, version 1.9 when I wrote this. I don't think they've hit 2 yet. And then Google didn't want this to be a Google product or a Google project specifically, so they worked with the Linux Foundation to create the Cloud Native Compute Foundation to donate it to, so that the community could actually own itself. And so that was pretty cool of Google. Kubernetes is a platform built for running applications with like 20-something years of knowledge of how to run applications actually built into the system. Like AWS or GCP, it gives you a bunch of declarative APIs to describe how to deploy your resources, compute, network, and storage. But instead of VMs, it focuses on Linux containers, and instead of operating systems, it just focuses on applications. And that turns out to be really useful when you want to run applications. And it provides a very consistent user experience wherever you're needing to use it. If you're running it locally in your data center, if you're running it on your laptop, or you're running it up on GKE, the user experience is the same. You have the same Kubernetes manifests, and you access it the same way. And that's actually a pretty new thing, right? When have we actually been able to deploy things locally and to the cloud using the exact same tools? And then it has these core compute, network, and storage resources, and it extends those out with these things called controllers, which basically a control loop that sits there and watches Kubernetes and resources, and it can create, monitor, and perform actions on those resources to create higher-level resources. And we'll talk about some of the built-in controllers in a little bit. It is not a platform as a service. There's a lot of blogs and stuff out there that try and compare Kubernetes with Heroku or Kubernetes with Cloud Foundry, and they're really not the same thing. They're a different level of abstraction. When I'm talking to a PaaS, I say, I've got some source code, run it for me, I don't care. When we have Kubernetes, we're like, here's some source code. I just did a bunch of work to make it into a Docker image, and also I have a very prescribed way in which I want you to run it for me, and I'm going to tell you how to in YAML. I want to reiterate that Kubernetes is focused on running applications, not OSs, and it does so with the collective operations knowledge of companies like Google. And so things that we strive for in DevOps, such as centralized monitoring, centralized logging, is actually kind of built into Kubernetes and is considered table stakes. So Kubernetes is already watching all of the logs from your applications and all of the logs from itself, and it's already collecting metrics from itself and all of your applications. And you just simply run a couple of Kubernetes manifests to tell it where to send that to. So you can integrate with your existing Elk stack, your existing Splunk server, you can integrate it with Datadog or any of the other SaaS-based observability platforms, and it just works, and just start sending your stuff there. And that's great for the measurement part of CAMs, right? Because we're very quickly measuring what we're running in Kubernetes and hopefully able to correlate that to stuff we're running elsewhere and correlate it against our business objectives or whatever it is we're supposed to be doing. How do you run Kubernetes, or how do you get Kubernetes? Well, if you're in the cloud, you're in luck. Most of the clouds have a Kubernetes offering or are about to launch a Kubernetes offering. If you're on your laptop, you can use Minikube, or the new Docker for Mac, Docker for Windows actually come with a Kubernetes built into them as well. If you want to run it yourself in your own data centers, you should get help. I would say you should talk to Pivotal. We have the Pivotal Container Service, but there's a Kubernetes Partners website that lists dozens of people that will happily take your money and help you run Kubernetes. If you do want to run it yourself, you got to install the damn thing, right? You got to set up some servers, you got to configure an OS, you got to run config management, you got to do all that sort of stuff we were doing earlier. And there was a lot of companies. Turns out running clouds, running complex distributed systems is a hard problem. And a lot of companies tried and failed to run an OpenStack private cloud. Many people here have probably been involved in that unfortunate attempt. And those same companies are going to try and fail to install Kubernetes as well, having not learned anything from OpenStack. And even if you get it installed yourselves, you get it running, your CEO is not going to say, good job spending 6 months installing Kubernetes. He's going to know that you spent 6 months Kubernetes, but he won't be saying good job. So yeah, that whole Kubernetes thing. You're running it yourselves. This is what it looks like. It's got a lot of integration points, and it could be a Kubernetes cluster, or it could be a map of the Singapore transit system. If you're not running it yourself, you have Google running it for you. It looks a lot simpler. It looks like this. So you have a control plane, your Kubernetes master, and a data plane, the Kubernetes workers. And then you have etcd, which is the database that Kubernetes stores all of its state and information that it feels like it needs to keep for you. On the master, you have a couple of simple things, a scheduler, and an API server, and a controller manager. And they all do exactly what they say they do. Then on the workers, you have a kubelet, which which gets instructions from the Kubernetes scheduler and it performs actions on the worker node, such as running pods, which is the abstraction for a container in Kubernetes. And it works with Docker, and it works with your overlay networking to get it up and running and networked together. And you have the kube proxy, which manages your network connections, network policies, and helps control how things access your pods. Pods are the low-level compute resource that Kubernetes offers you. And a pod is actually made up of one or more containers. And actually, when you're using Docker, it's always more than one, that are tightly coupled. They share an execution environment, which means they share a network, so they can talk to each other over localhost, which is super useful, and they share storage. A deployment is a Kubernetes controller that actually ensures that a set number of replicas of a pod is running. So say I want 4 copies of my Nginx, it will say, okay, give me 4 pods and make sure 4 pods are always running. And so Kubernetes will manage that for me, so I don't have to continually be running my, my config management client or whatever to keep that happening. And it also provides update and upgrade workflows for your pods. So you can say, hey, I want you to, when I upgrade my pods, I want you to do it 2 at a time. And when it comes up completely, destroy the 2 old ones and then move on to the next pair. And Kubernetes will just manage that for you and handle that for you. And then you have a stateful set, which actually extends the deployment controller even further to make it easier to deploy stateful applications and things like Cassandra databases. And it does this by providing sticky identity, strict ordering, and uniqueness to your pods, so they become a lot more deterministic. And it also works with persistent volumes to make sure that your volumes persist beyond the life cycle of a pod. Services are the network resource, and they basically track pods based on labels that you give to those pods. And they provide connectivity via load balancing and service discovery. They provide service discovery in the form of kubedns and also environment variables, if you prefer environment variables. And then it makes those apps available a number of different ways. The default is a cluster IP, which is just an IP address that exists on each worker node that then load balances to any pods that the service knows about. And then that gets extended by a node port when you want to have something external access it by taking a static port on each worker node's IP address and mapping it to that cluster IP. So now anything outside of the cluster that can access my worker node's IP addresses can access my app. And then you have the load balancer resource, which actually just goes out to your cloud and says, give me a load balancer, map it to this node port, which goes to the cluster IP, which goes to my pods. And so it all just kind of wires this up for you. And then you have an ingress controller, which extends that even further to not only configure the load balancing, but also SSL termination, name-based virtual hosting, and other like layer 7 load balancing kind of techniques, based on a set of rules you pass in when you declare the ingress. Volumes are effectively a directory mapped into all the containers in a pod. They usually share the lifecycle of a pod, but you can do a persistent volume, which lives longer than the pod, so that you can start looking at the stateful sets and stateful applications. And there's about 30-odd storage drivers, so you can do anything from mounting from a local disk to iSCSI, NFS, or whatever your cloud provider's block storage options are. You have config maps and secrets. They're just key value pairs that get injected into a pod, much like you inject user data into a cloud server. And you do that, basically anything you would set in an environment variable in Docker, you can set in a config map or a secret. And it stores them, it injects them as either a volume or environment variable into your pod, so that then your applications can read from files or read from environment variables to figure out what to do. Perfect for last-minute configuration of things. Secrets aren't much different to config maps. They're base 64 encoded strings to allow you to have binary secrets, and they're not currently encrypted by default, but that will come at some point soon when some features move from beta into non-beta. Kubernetes manifest is what you use to kind of declare the state you want and tell Kubernetes to go out and make that state reality. It's a fairly simple data structure. You can write it in YAML or JSON if you really hate yourself. And it looks a little bit like this. So this is how I can run my Hello World app. So I have a deployment. I say I want 2 replicas, and I give it some labels. And then on my service, I say, hey, I want a node port of port 80, and I want you to know about any pods that have the label Hello World. And then I send them off to Kubernetes, and it assembles my app. It connects my app together, and then I can hit any IP address on my worker nodes, and I can get to my app. But that's not enough. I want it load balanced, and I also have a second service that I want to access, and I want to be able to do that via URL paths. So I can have two different apps acting as kind of one website. And so I say, I want anything going to the URL path /hello to the hello service, anything going to the URL path /goodbye to the goodbye service. And it just wires that up for me, and I can run kubectl apply, send it to my manifest directory, and then once it's finished, I can curl either of those URLs and get my appropriate app. But it's a fairly static thing, right? It's a bunch of YAML. So I can define a database by passing in a config map like so. But if I want to have multiple environments and multiple databases for those environments, I've got no real way to define those in Kubernetes manifests other than a bunch of copying and pasting or doing something really tragic like piping stuff through sed or something. And so the Kubernetes community saw that as a problem, and they built Helm. So Helm is a package manager for Kubernetes manifests. It's a directory with a chart file, which is metadata about the chart, a bunch of default values, and a bunch of templated out Kubernetes manifests. And then it tars that up, it signs them, and ships them up to a Helm repo. And there's about 150 apps already built and shared at the managed Helm chart repo. So pretty much any app you want to run, someone's probably already written a Helm chart for it. You have the Helm client, which is a CLI that helps you actually develop the charts and also run the charts. And so when you tell Helm to run a chart, it talks to the Tiller server, which helps compile the templates together and render them out, and then tell Kubernetes to run them for you. So I template out my app, something like this. You can see I've got my database value templated out. I've got my node port templated out. And then I've got all of my metadata and labels templated out. And so when I put these together and I tell Helm to run it, by giving it a release name and a different database, I can now run a staging environment and a production environment from the same set of manifests on the same Kubernetes cluster or different Kubernetes clusters quite easily. And so it starts making what we do quite portable and improves things a lot. And I'm running low on time, so next steps, I've got a bunch of docs you can read. I wrote a blog post on writing your first Helm chart. Pivotal has a Pivotal Container Service, which is our enterprise Kubernetes offering. And then I highly recommend watching Kelsey Hightower's keynote from Austin, where he was demonstrating a CI/CD pipeline of deploying an app using kind of the Git flow workflows. No questions? Thank you very much.